Hi, welcome to class. My name is Don LaFon, Professor Don. You were just with me, most likely, in Module 10, the abbreviated Module 10 presentation. Now, we're going to cover Module 11 presentation, Switch Security Configuration. Now, to keep concepts simple for myself primarily, but I'm sure it's going to help you as well, I moved all of the problems from Module 10 into Module 11, followed by their mitigation. So problem mitigation, problem mitigation, problem mitigation. It works, I think it's going to work a lot better than the way it was before, where all the problems were in Module 10 and the mitigation is in Module 11. It's the same slides, but this presentation is going to be more thorough. Now, we covered AAA, the authorization, authentication, authorization, and accounting, AAA, in the previous presentation. We're past that now. We're going to talk about actual issues that you're going to run into dealing with security in a Cisco operating environment. So let's go ahead and get the presentation started. If you have any questions, I'd like you to ask those questions inside of our help discussion forum if you're watching this as a recording. If you're watching this with me right now, what I would like you to do is I'd like you to hold your questions until we get to the end of the presentation, and then I'll give you a question and answer period where you'll be able to ask some questions. So make notes of any questions you might run into. In this presentation, you might actually run into some questions. I'll be happy to help you at the end of the presentation. This presentation, I believe, is going to be right at an hour. It's 70 slides long and a minute a slide. That's easy to go through. So grab yourself your favorite beverage, relax, and let's get through this presentation. The first thing, and these concepts, these very important concepts. Let me go ahead and share my screen. And one more thing, I gotta pull this over to the other monitor for simplicity, and we are ready. So Module 11, Switch Security Configuration. In this presentation, we're going to talk about implementing port security on the ports on a switch. We're going to talk about how to mitigate. Well, actually, we're going to talk about the actual VLAN attacks, what they are, and how to mitigate. We'll talk about DTP and how to configure DTP and native VLANs to mitigate VLAN attacks. We'll talk about what DHCP attacks are and how to mitigate them. Talk about ARP attacks and STP attacks, and talk about how to mitigate those issues as well. Implementing port security. So recall that the OSI reference model is divided into 7 layers which work independently of each other. This figure shows the function of each layer and the core elements that can be exploited. Network administrators routinely implement security solutions to protect the elements in layer 3 and up through layer 7. They do that by using VPNs, firewalls, IPS devices at layer 2. Or actually, they implement those that's a little confusing there. They implement those all over the place, but we need to be aware at layer 2, we need to stop people from, say, a threat actor taking a laptop computer and just connecting to the switch. And then they can bypass all of the VPNs, firewalls, IPS, all the devices because they're actually in your network. So we need to implement security at the layer 2 device as well. Yep. Because if you are compromised at layer 2, obviously everything above layer 2 is compromised as well. Now, security is only as strong as the weakest link in the system, and layer 2 is considered to be that weak link. This is because LANs were traditionally under administrative controls of a single organization. We inherently trusted all persons and devices connected to our LAN. Today, with BYOD, bring your own devices, and more sophisticated attacks, our LANs have become more vulnerable to penetration. And the examples they give are MAC table attacks, which include MAC access flooding attacks, VLAN attacks, which includes VLAN hopping and VLAN double tagging attacks. It also includes attacks between devices on a common VLAN. DHCP attacks, including DHCP starvation and DHCP spoofing attacks. ARP attacks, which include ARP spoofing and ARP poison attacks. Address spoofing attacks, which include MAC address and IP address spoofing attacks. And STP attacks, which include spanning tree protocol manipulation attacks. Now, just to reiterate why I combined the two, previously what they did was they taught all of these categories of attacks in Module 10. That's why it's important for you to review Module 10 of our NetAcad course. Go in and read about these things because that's where you're going to get the details of each of these attacks in Module 10. In Module 11, they talk about mitigation. They talk about how to prevent these attacks. So having it in two different presentations was a little challenging for me when I was reviewing how to teach this concept. So I combined them in this one presentation. Makes for a longer presentation, and I apologize for that, but it will help you to learn the concepts, I believe, better. Now, and you might be able to be better jumping back and forth from Module 10 to 11. Learn a concept in Module 10, go learn about how to mitigate it in Module 11. Learn about another issue in like port security, DHCP snooping, dynamic ARP inspection, and then come back to Module 11 and learn about what the mitigation techniques are to be able to prevent those type of actions, those types of those are solutions, those aren't attacks. So port security, DHCP snooping, dynamic ARP inspection, and ARP security guard are all types of mitigation techniques, and those different types of mitigation techniques are presented in this presentation. These layer 2 solutions will not be affected if the management protocols are not secured. The following strategies are recommended. Always use secure variants of management protocols such as SSH, that's Secure Copy Protocol instead of Telnet, Secure FTP, SFTP, Secure Copy Protocol, SCP, Secure Socket Layer, SSL, and TSL, Transport Layer Security. Consider using out-of-band management networks to manage devices. That means have some devices not even connected to the internet, and those devices ultimately are where you perform your most sensitive material. You actually have to walk up to the device and use it. Of course, if you're plugging a USB in, well, so much for being out of band, because as soon as you plug in a USB drive into that piece of equipment that's not connected to the internet, guess what? It's possible for some sort of malicious software to transfer from the USB to the device itself. And if you're updating the device, you're like, well, I won't allow it. But what happens when you're updating the device, right? So out of band is often difficult to truly be out of band. Use a dedicated management VLAN where nothing but management traffic resides. For example, you don't have to leave a VLAN 1 as your management VLAN. You can move it to VLAN 99 or management to VLAN 99 or another one that isn't so obvious. And you can use ACLs to filter unwanted access. Now, switch operation review. Recall that to make forwarding decisions, a layer 2 LAN switch builds a table based on the source MAC address it receives in frames. This is called a MAC address table. A MAC address table MAC address tables are stored in memory and are used to manage a switch efficiently. MAC address table flooding, all MAC tables have a fixed size, and consequently, a switch can run out of resources in which to store MAC addresses. MAC address flooding attacks take advantage of this limitation by bombarding the switch with fake source MAC addresses until the switch runs out of address space. When this occurs, the switch treats the frame as an unknown unicast and begins to flood all incoming traffic out all ports on the same VLAN without referencing the MAC table. This condition now allows a threat actor to capture all of the frames sent from one host to another on a local LAN or local VLAN. Note, traffic is flooded only within the local LAN or VLAN. The threat actor can only capture traffic within the local LAN or VLAN to which the threat actor is connected. Just zoom in on that picture. Ooh, the bad guy. He runs a program like MacOff, and it overflows the MAC table, and then the MAC floods all the frames with all of the information, and then the threat actor captures that traffic, and it now can try to use that information to gain confidential information or private information. Now what makes tools such as MacOff so dangerous is that an attacker can create MAC table overflow attack very quickly. For instance, a Catalyst 6500 switch can store 132,000 MAC addresses in its MAC address table. A tool such as MacOff can flood a switch with up to 8,000 bogus frames per second, creating a MAC table overflow in a matter of just a few seconds. Another reason why these attack tools are dangerous is because they not only affect the local switch, but they can also affect other connected layer 2 switches. When the MAC address table is switched to full, it starts flooding out all ports, including those connected to other layer 2 switches. To mitigate MAC address table overflow attacks, network administrators must implement port security. Port security will only allow a specified number of source MAC addresses to be learned on the port. Port security is further discussed right now because we're going to continue talking about this. Anyways, I do want to point out that this is the one true configuration that you need to learn these configuration steps about how to set the MAC port security on a switch port on a switch. It is the most important thing to pull out of these chapters when it comes to configuration. Layer 2 attacks are some of the easiest for hackers to deploy, but these threats can also be mitigated with some common Layer 2 solutions. All switch port interfaces should be secured before the switch is deployed for production use. How a port is secured depending on its function. Before I read the next line, I just want to reiterate, when you take a switch out of a box, all of the ports are open. You connect a router or a host to any port on the switch, and it starts communicating immediately. So unlike a router that you have to type no shut to bring up a port on a router, on a switch, everything is automatically up. You can prove that yourself. Just order a switch on a switch on a Newegg or someplace, plug it in to a device. It immediately works without any configuration at all. All right, 1 second, please. A simple method that many administrators use to help secure the network from unauthorized access is to disable all unused ports on a switch. Navigate to each unused ports and issue the Cisco iOS shutdown command. If a port must be reactivated at a later time, well, you can just use the no shutdown command to bring it up. Just like on a router, you can shut down ports on a switch using the shutdown command. You can even get a range of ports using the interface range command. So let's say you have 24 ports on a switch. You can type switch interface range the first module number, so F01 to 24-24, hit enter, and you now are in a range, and then you just configure, then you just type shutdown, and you just shut down all of the ports on the switch, assuming there's 24 ports, that is. The simplest and most effective method to prevent MAC address table overflow attacks is to enable port security. Port security limits the number of valid MAC addresses allowed on the port. It allows an administrator to manually configure MAC address for a port or to permit the switch to dynamically learn a limited number of MAC addresses. When a port configured with port security receives a frame, the source MAC address of the frame is compared to the list of secured source MAC addresses that were manually configured or dynamically learned on the port. By limiting the number of permitted MAC addresses on a port to 1, port security can be used to control unauthorized access to the network. And I know this for a fact, it works, because if you've ever been in a classroom and you just try to take a network connection that's working perfectly fine on computer A and move it to computer B that does not have an internet connection, if you take it from A and you put it in B, B won't work, or at least it shouldn't work. It shouldn't work on computer B, even though it was working perfectly fine on one, because security has been placed based on the MAC address of PC A. I know that for a fact because I tried it in our classroom, and I was not able to move a perfectly good network connection from one computer to the other because of security set at the MAC layer. Port security is enabled with the switch port security interface configuration command. Notice in the example, the switch port security command was rejected. This is because port security can only be configured on a manually configured access port or manually configured trunk ports. By default, layer 2 switches are set to dynamic auto trunking on. Therefore, in this example, the port is configured first with switchport mode access interface configuration command. So what happens is they try to use the command switchport port security to start to enable port security, but they get an error message saying that it's a dynamic port. Now, this will actually happen with your equipment, and the next step is like, oh yeah, it's dynamic. I need to make it manually an access port or manually a trunk port. And the command to make it an access port is switchport mode access. So you type switchport mode access. Now you can enable port security, and you can end that command. There's more though. Don't worry, we'll get into it. Use the switch port. You can use the show port securities interface command to display the current port security settings for a port. Notice how port security is enabled, the violation mode is shut down, and how the maximum number of MAC addresses is 1. That is configurable though. If a device is connected to a port, the switch will automatically add devices' MAC addresses as a secure MAC. In this example, no device is connected to the port. Note, if an active port is configured with switchport port security command and more than one device is connected to that port, the port will transition to the error disabled state. I'll cover that in just a moment. Now, after port security is enabled, other port security specifications can be configured as shown. Now you can set, and the best way to do this, believe it or not, is to type, you believe it, I know you do, in my class, well, we all love the question mark command. You type switch port security, just as if you were just enabling it with the default settings, and then a space, and then the question mark. And then you get aging. That talks about switchport port aging commands, MAC addresses, secure MAC address, the number of secure MAC addresses before it stops accepting them, and violation. There's 3 different violations. We'll cover them in just a moment, or you can hit enter, which just gives you the default settings. Now, to set the maximum number of MAC addresses allowed on a port, use the following command: switchport in global configuration mode, switchport, port security, maximum, and then whatever that number is. So if you want, the default's 1, you can set it to 3, the maximum number of 5, whatever you want. The maximum number of secure MAC addresses that can be configured depends on the switch and the iOS. In this example, the maximum of 8 is 8,192, and you can see that command here. The setup, and then, no, they don't show it, but it's pretty simple, just to enter a number. Now, the switch can be configured to learn about MAC addresses on a secure port in one of 3 ways. It can be configured manually. The administrator manually configures a static MAC address by using the following commands for each secure MAC address on the port: switch port, port security, MAC address, and then you enter the actual MAC address. Now, you can add multiple manual MAC addresses that are allowed on that port by just using that same command, a second, a third, or fourth command. Now, that sounds like the way to do things, but it is really easy to make typos when you're adding MAC addresses. So a better way to doing that is to allow for sticky. We'll get to there for a second. You will allow it to be dynamically learned, and then you want it to be sticky. Now, when you dynamically learn an address, you use the switchport port security command again. The current source MAC address for the address connected to the port is automatically secured, but is not added to the running configuration. If the switch is rebooted, then that goes away, and then you have to relearn whatever computer is connected to that port. So all somebody would have to do is reload your switch with their PC, their laptop connected to the switch, and it would learn that MAC address, kind of defeating the whole purpose of having switchport port security. So that's where sticky comes into play. So the administrator can enable the switch to dynamically learn the first MAC address that sticks, the first one that's connected to the port sticks to the running configuration. And it's dynamically learned and saved to NVRAM. Now, again, you're like, well, what if that person, blah, blah, blah. All right, so this is how it works. If you are configuring a lab with 24 computers to a switch with 24 ports, you know that all you need to do is to make the maximum, which we learned previously, which is the default value of 1. We set the maximum of 1, and then you just connect the PC that's in the classroom to the port. It learns that port, and if you have it set up as dynamic sticky, it then saves that port, that information for when you walk out of the lab and you are able, you walk out of the lab and you and the equipment goes off and it comes back on again. You don't have to show back up at that equipment. So that definitely serves both purposes: configuring the equipment and making it secure. All right. Here's an example of limiting and learning that MAC address. So the example demonstrated a complete port security configuration for F01. The administrator specifies a maximum of 4 MAC addresses, manually configures 1 secure MAC address, and then configures the port to dynamically learn additional secure MAC addresses up to the 4 secure MAC addresses maximum. Use the show port security interface and show port security address command to verify the configuration. So there at the top, you can see the actual configuration. Let me zoom in on it so we can focus on one area of this. And we have switchport mode access. We turn it on with switchport port security. Then we set it to maximum of 4. The first example gives you port security MAC address, and then there is the MAC address of that first device. And then we make it sticky. So actually, in this case, the next three will be learned. The first one is already learned. Then when we get out of it, you can see the details. It is secure up. The violation mode we haven't set to anything else, but so it is set to shutdown. We'll talk about that more when we get there. The aging type is absolute. We'll talk about aging later. Maximum is 4. 1 has been learned, right? 1 has been manually configured. And then down here, it shows that learned or manually configured device, right? So if you were to use this same command, the show port security interface, whatever interface you're on, after you've connected 3 devices, after you connected 7 devices, it's only going to show you the first 4 that were learned. Port security aging. Port security aging can be used to set the aging time for static and dynamic secure addresses on a port, and 2 types of aging are supported per port. There's absolute. That's when the secure addresses on the port are deleted after a specific aging period of time. Inactivity, the secure addresses on the port are deleted if they are inactive for a specific period of time. Use aging to remove secure MAC addresses on a port without manually deleting the existing secure MAC address. Aging of statically configured secure addresses can be enabled and disabled on a per port basis. So this is actually how you can clear a manually configured port that's been learned. You can turn on aging, and then it will clear that one you went in and manually configured. Use the Switchboard port security aging command to enable or disable static aging for the secure port, or to set the aging time or type. Switchboard port security aging, and then static, give it a time, or absolute, and then absolute or inactivity. Now, I want to point out one other way that you might want to use aging. Let's say you have a conference that's going on, and you have a bunch of equipment that is connected to a switch, and you know when that conference is over, everybody's going to disconnect. They're going to bring their own equipment. They're going to connect. They're going to disconnect at the end of the conference. It would be a good idea to set aging to just automatically wipe the switch when the conference is over in a period of days. Now, this example shows an administrator configuring the aging type to 10 minutes of inactivity. The show port security command confirms the change. So I'm not going to zoom in. It's pretty easy to see. Interface, whatever interface you're looking at, port security, aging time, 10, right? And then that's 10 minutes. Type, inactivity. So if somebody disconnects to the port for more than 10 minutes, that MAC address is going to be lost. It's going to be removed. And another person would be able to connect to that device. Maybe this is a good example of say in, I think the student lounge at least on one of the campuses, you can physically connect to not a wireless port, but a RJ45 port. You can connect to that port, and you can, when you disconnect, maybe, again, they're concerned about MAC cable flooding. So maybe you disconnect and after 10 minutes or 1 minute, you disconnect, it erases your MAC address, but that still serves a purpose, allowing of a maximum number of MAC addresses to be connected to that port. All right, there we go. And then show port security interface FA01, and then you can see secure shutdown. We still haven't talked about that. We have talked about secure shutdown. We haven't talked about restrict yet. We'll come back to that in a minute. 10 minutes, inactivity, and there is the MAC address that's been learned. Now here we are finally going to talk about violation modes. Now, if the MAC address of a device attached to a port differs from the list of secure addresses, Then a port violation occurs and the port enters the error disabled state. Now, to set the port security violation mode, use the following command. Switchboard, port security, nothing different, and then the question mark, because you're going to forget the next command, and it's going to say violation. You type in violation, and then you pick from either shutdown, restrict, or protect. Now, shutdown, the port transitions to the error disable state immediately. It turns off the port LED and sends a syslog message to the people managing the equipment. It increments the violation counter. When a secure port is in the error disabled state, an administrator must actually re-enable that port by first entering the shutdown command and then no shutdown. Now, many of you right now are thinking, wait, it's already shut down. Why would we need to go shutdown? Well, just think of a push button, right? Sometimes you have to push further. You push down, it sticks. And then to push down again, you have to go down further to come back up again, right? Push down, it sticks. Push down further to go back up again. Well, that's how I remember that error disabled actually puts that port into something that's below shutdown. So the only way to get it back up to shutdown is you have to put it no shutdown, and then it'll come back up again. I'm sorry, no shutdown, and then you can do no shutdown and bring it back up again. Just think about that push button switch that you need to push down further to re-enable it. Then there's restrict. The port drops all packets with unknown source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value. This mode causes the security violation counter to increment and generates a syslog message saying that there's an issue going on, come take a look. Whoever's monitoring the equipment will take a look at that. Then there's protect. This is the least secure of the security violation modes. The port drops the packets with unknown MAC source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value, but no syslog message is sent. So it does drop the packets, but nobody's told why. So this is the one where somebody will reach out to you and say, hey, I can't use my PC. It's not talking anymore to the network. They'll ask you if you can talk to local connections. You'll say, I can't talk to anybody. Well, then they're going to look at it and they'll probably find that the port has been dropping packets because it had a security violation if you only have it in protect. Now, you need to figure out a way to remember the levels. Now, fortunately, it is in alphabetical order from the least effective, protect, to the more restrictive, restrict, to just shutting down the port. So P, Q, R, S, right? So it's in alphabetical order from the least to the most. The least is protect. It drops packets but doesn't tell anybody. To restrict, it drops packets, but it tells you. And then shutdown, it just shuts down the port into that error disable state. So just remember, it's in alphabetical order from least to strongest, and it'll help you to remember that. Again, do a question mark. You're probably not going to remember these three. Just do a question mark when you get here, violation question mark, and it'll offer you the three. And I do believe it actually tells you which ones are which. I don't remember exactly right now, but I'm pretty sure it says what they do. Not positive about that though. This example shows the administrator changing the security violation to restrict. The output of the show command now shows that we have gone from shutdown to restrict. And the command is switchboard put security violation restrict. Okay. Now, when a port is in shutdown and placed in the error disabled state, no traffic is sent or received down the port. A series of port security related messages display on the console as shown in the following example. And here you'll see that it's in an error disabled state and it's a level 4 alert that's being sent. Now, levels are 1 through, there are 7 levels. I believe it's 0 through 6 or 1 through 7. I apologize for not remembering that. And it 1 is the, I think it's 1 through 7. 1 is the most important error. That's I believe, and we learned this later in this class, I believe. 1 is where you have a critical error. So you can see a 4 is an important error. It says it's in error disabled, and it's in an error disabled state. Now you need to go in there, and you need and then here's a level 2 error. A security violation occurred because a specific MAC address that was unauthorized accessed port 018, and you can see that the protocol went to off, to down, and the state was changed to down as well. So these are error messages that you will get when an occurrence happens. And those could be ported out to somebody managing the equipment remotely. Now in ports in error disabled state, in using the show interface command identifies the port status as error disabled. The output of the show port security interface command now shows port status as secure shutdown. That was here. And then the port status as shutdown. Again, to re-enable this port, you need to first use the shutdown command and then use the no shutdown command. To verify port security after configuring the security on the switch, check each interface to verify that the port security is set correctly, and check to ensure that the static MAC addresses have been properly configured. Again, show port security command will list all interfaces as they're configured and how many have been, how many are maximum, how many are currently addressed, if any are in violation count, and if any are shut down, if any are in error disabled. That's the bad one that you are concerned about. You can also use the show port security command to view details on specific interfaces just by going to that interface. Show port security and then the interface. And here it shows that it's been configured, maximum 10, sticky, and then they manually configured one of them as a sticky to ensure that. And here you can see one was learned dynamically and it's saved, and one was learned that you manually put in and made it sticky. You're going to do a packet tracer on implementing port security. Again, this is the most challenging part. It is the one you configure. Most of the rest of this presentation is just informational in nature to teach you how we do things. But the port security, this is critical because you are going to have port security in it. You're going to do it often when you're out in the field, and you're going to do it again in Cisco 3 if you take that class next semester or in the near future. Mitigating VLAN attacks. We have some VLAN videos that I'm going to go ahead and prepare and open. I'm going to pause the presentation and get to the videos because it's important to you to see the videos to help you understand the concepts. All right, I have that video set up now. I'm going to go ahead and start it.
A VLAN hopping attack is going to enable traffic from one virtual local area network to be seen by another virtual local area network. And this is without the aid of a device such as a router. This is a basic VLAN hopping attack. A threat actor is going to configure a host to act just like a switch. And then using that host, they're going to take advantage of the automatic trunking port feature that's enabled by default on most switch ports. This would be the modes of dynamic auto or dynamic desirable on the switch ports. The threat actor is going to configure the host to spoof those 802.1q signaling and those DTP messages so that the trunk will form between the host and the switch. With a successful trunk established, They're going to be able to send and receive traffic on any virtual local area network, effectively hopping between any VLANs that they want to connect through. With a VLAN double tagging attack, a threat actor is going to embed a hidden 802.1q VLAN tag inside of a frame that already has an 802.1q VLAN tag. What's going to happen here is we're going to have an attacker that's going to double tag a frame. For example, our attacker was going to build a message that's going to communicate from its current VLAN, which is VLAN 10, with a targeted VLAN of VLAN 20. With the attacker currently being on VLAN 10, they're going to build a frame that's going to have an external VLAN header on it, a VLAN 10, and then an internal tagged VLAN of VLAN 20. When that message is sent up to the first switch, our first switch is going to see the external outside header of VLAN 10. It's going to strip that off and then send this traffic on its way to any device running VLAN 10. Well, the switch sees that VLAN 10 is also the native VLAN, so it's going to remove the VLAN 10 header and move it across the trunk link. Now, as that frame moves across the trunk link, the first header of VLAN 10 was removed. And now the internal tag, which is the VLAN 20, that still exists. This second switch is going to receive that frame. It's going to strip off that VLAN 20 header, and then it's going to forward it out any VLAN 20 ports, which includes down to that targeted host. This is effectively allowing our threat actor machine on VLAN 10 to communicate to the target on VLAN 20 using a double tag. Now, VLAN hopping and this whole idea of VLAN double tagging, they can both be prevented by putting in a couple security guidelines. Number one, we should get rid of trunking on any access port that goes to end devices. Also, the whole idea of auto trunking, using things like dynamic desirable and dynamic auto, that should be disabled. We should use a manual static trunking as needed. Also, native VLAN should only be used on trunk links, and that native VLAN should never span to a user device. For instance, in this scenario only works when the threat actor is on the same VLAN as the native VLAN between our switches. DHCP is a powerful tool for easy dynamic addressing across our networks, but it can also be a powerful tool for malicious threat actors that want to have some fun with a network. So, quick recap of DHCP. We have DHCP servers that are going to dynamically provide addressing for us. That addressing includes IP addresses, subnet masks, default gateway, DNS servers, and even more with DHCP options to our clients. The typical conversation with DHCP goes back to DORA: discover, offer, request, acknowledge. Our client's going to send a broadcast message, which is a discover. A server is going to hear that broadcast message and respond with a unicast offer of, this is what I can give you. Here's some addressing info. The client receives that offer, it's very excited, and it sends out a broadcast of, I accept the offer you sent me. That server finishes it up with a unicast saying, you like the offer, I'm glad, I acknowledge. And then the lease is complete regarding the client taking that addressing info. It sounds easy enough, but now let's bring in an attack. Now it sounds funny saying it, but there's two common types of DHCP attacks. We've got the DHCP starvation attack and DHCP spoofing. With DHCP starvation, the goal of the threat actor is to create a denial of service for your connecting clients. What would happen is the threat actor would gobble up all of the usable DHCP provided addresses. The easiest way to go about this is having a threat actor using a client machine that's cycling through source MAC addresses very quickly, and for each source MAC address, gobbling up an available IP address being given by your DHCP server. When all the addresses are taken from the DHCP server, there's nothing to provide the legitimate clients. On top of that, there's the DHCP spoofing attack. Imagine having a threat actor putting out their own DHCP server on your network. And when your clients use the whole DORA process and they broadcast out for a discover, and then there's the offer, the request, but then your rogue DHCP server finishes the conversation with the client with an acknowledgement providing wrong default gateway info, incorrect DNS servers, as well as even wrong IP addresses for the clients to use. Effectively, your legitimate clients cannot communicate on the network. So we have to prevent this by using safeguards and implementations for security.
It might have been a good idea to separate those two out, but that's what we're going to talk about over the next couple minutes, we're going to talk about those concerns. Let me bring this back up to the front. There we go. And to the next slide. Great. So VLAN hopping attack. So he just explained how the hopping attack happens. So I am just going to, I think I'm going to skip these because me just reading what he just said for the actual attack isn't necessary. What you want to know is mitigation. So the mitigation, what we want to do is we want to disable trunking on all access ports. We want to disable auto trunking on trunk links so that trunks must be manually enabled. And we need to make sure that the native VLAN is only used for trunk links. And then they go back and they explain how to the VLAN attack. And here's how to mitigate VLAN hopping attacks. Now, the following steps mitigate VLAN hopping attacks. First, disable DTP, auto trunking, remember auto trunking negotiation on non-trunking ports by using the switch port mode access, making it an access port instead of a trunk port. Disable unused ports and put them in the unused VLAN. Create a VLAN called garbage, for example, and put all ports that are not used in that VLAN. Manually enable the trunk link on trunk ports by using the switch port mode trunk. So you're manually configuring the trunk, not dynamically configuring it. Disable DTP, that's auto trunking negotiation on trunk ports by using the switch port non-negotiate command, and then set the native VLAN to a VLAN other than VLAN 1 by using switch port trunk native VLAN, and then give it a VLAN that's not one of your other VLANs that are used. And here they actually give you an example of those configurations in work. So we have switch port mode access, putting it in access port, access mode, putting the port 17 through 20 in VLAN 1000, which we're going to use as our garbage. You should have named it as well while you were there. And then here, going to the ports and disabling DTP by not using the non-negotiate command, and then putting the native VLAN into a VLAN that's not used by one of the other VLANs in your equipment. Okay, so that is that. And now mitigating DHCP attacks. Now the video showed how DHCP attacks happens. I'm not going to show that again. And here they just talk about I'm not going to read those to you. And this is actually a little bit more in detail. So I'll talk. So the goal of DHCP starvation attacks is to using an attack tool such as Gobbler to create a denial of service for connecting clients. Recall that DHCP starvation attacks can be effectively mitigated by using port security because Gobbler uses a unique source MAC address for each DHCP request sent. However, mitigating DHCP spoofing attacks requires more protection. Gobbler could be configured to use the actual interface MAC address as the source Ethernet address, but specifically a different Ethernet address and a DHCP payload. This would render port security ineffective because the source MAC address would be legitimate. So we need to mitigate DHCP on trusted ports. So DHCP snooping filters DHCP messages and rate limits DHCP traffic on untrusted ports. So by making them trusted ports, then enabling DHCP snooping, you solve this issue. DHCP devices that are under administrative control, switches, routers, and servers, for example, are trusted sources. Trusted interfaces, trunk links, server ports, must be explicitly configured as trusted. Devices outside the network and all access ports are generally treated as untrusted sources. A DHCP table is built that includes the source MAC address of the device on an untrusted port and the IP address assigned by the DHCP server to that device. The MAC address and the IP address are bound together. Therefore, this table is called a DHCP snooping binding table. Now, to implement DHCP snooping, you want to enable DHCP snooping by using the IP DHCP snooping global configuration command. Then go to each trusted port and type IP DHCP snooping trust, an interface configuration command. On untrusted port, limit the number of DHCP discovery messages that can be received using the IP DHCP snooping limit rate, and then how many packets per second interface packet per second you want to be allowed on the interface, and then enable DHC snooping by VLAN or by a range of VLANs by using the IP DHCP snooping, and then put in the VLAN that you want to work. Now here is what it actually looks like. We have IP DHCP snooping. That's the first command. You have to turn it on, and then you go to F01 here on S1, and you type IP DHCP. You go to the interface and you type IP DHCP snooping trust. This makes this a trusted interface. Now, untrusted ports, all access ports are by default untrusted. And then you can go to the range, interface range F05 through 24. That would be all of, for example, these ports here, and type IP DHCP snooping limit rate 6. And this would only allow 6 DHCP requests per second. And finally, DHCP snooping VLAN 5, 10, 50 through 52 actually enables DHCP snooping on 5, 10, 50, 51, and 52. Not too hard. Actually, this command is pretty obvious, and all you got to do is remember snooping to be able to remember the command, because it's just show IP DHCP snooping, which is pretty simple, and everything is a question mark afterwards if you forget. Show IP DHCP snooping makes sense. It verifies that DHCP snooping settings, what they are set to, and show IP DHCP snooping binding to see what clients have received DHCP information. You can see that down here, and we have one binding, one MAC address to one IP address has been bound. Mitigating ARP attacks. There is a video to help us understand the concepts. Let me pull that up. Oops, maybe another one. Yep. And DHCP, ARP attacks, and then the video. All right. The filter is better. Defining stuff like that. Here it is right here. And here we go.
Address resolution protocol is a powerful protocol on our networks that allow our networks to function. With ARP, we're talking about having a known IP address being mapped to an unknown MAC address. And this is being used all the time with our devices on the network. Now, a client can send an unsolicited ARP reply, which is known as a gratuitous ARP. It's really a broadcast that we have a specific IP address that is mapped to a specific MAC address. Now, the problem is when someone sends out a gratuitous ARP as a broadcast, other devices, which would be hosts as well as network switches, are going to store that MAC address and IP address combo in their ARP tables and MAC address tables. This is an issue because a threat actor can send a gratuitous ARP message with spoofed information inside of it. This effectively allows any host to claim to be the owner of any IP address and MAC address combo that they want to. So let's talk about it. Here in our graphic, we've got PC1, PC2, and R1. They all have ARP caches that are up to date and correct. But what's going to happen here is PC2, the threat actor, is going to send out a gratuitous ARP. And that gratuitous ARP is going to claim that 10.0.0.1, the IP address of the router, is reachable by using MAC address all Cs, which is the MAC address of the threat actor. Also, the threat actor PC2 sends out a gratuitous ARP claiming that 10.0.0.11, which is the IP address of PC1, is reachable with MAC address all Cs, which is again the attacker. So what's going to happen here is when PC1 sends data to the 10.0.0.1 IP address, it'll be sending it at layer 2 to the attacker, which is all Cs. When the attacker receives this data, it'll be using it as a man-in-the-middle attack. When the router responds to 10.0.0.11, the router will be responding to the layer 2 target, the MAC address of all Cs, which again is going to be the threat actor. So what it comes down to is exactly this. PC1 will want to send data to 10.0.0.1, and to do so, it'll send it to the MAC address of all Cs, which is PC2. PC2 forwards that data onto the router. The router will send it outbound to where it needs to go. As the router responds back to the 10.0.0.11 IP address, it'll be responding back, targeting all Cs, again the MAC address of the threat actor. This is a beautiful man-in-the-middle attack. Spanning tree is a protocol that is on by default on our Cisco switches. Its job is to provide us redundant connections while maintaining loop-free pathways, and it does it great. But the problem is threat actors can utilize spanning tree to actually change the topology of your network infrastructure. Now, the way they would do this is based off of logical, not based off of physical connections, but they would make their host appear as a root bridge. To do this, they would be sending out bridge protocol data units, which are spanning tree layer 2 messages. And these messages will include a priority of something insanely low, such as 0, for example, here in our graphic. By sending out these spanning tree messages saying that their priority is insanely good, the network infrastructure will view that threat actor's host, which is pretending to be a switch, as the root bridge, and they will all find the best way to reach the root bridge, which means they'll be dropping their main connection between each other and connecting through that switch itself. This allows the threat actor machine to pretty much act as a man-in-the-middle style attack and to be able to see all network traffic moving across this network domain. Cisco Discovery Protocol is a Cisco proprietary layer 2 link discovery protocol. This thing is amazing. It can be used to verify layer 1 and layer 2 connectivity. And the cool thing is it's on by default on all Cisco devices. Now, on that same point, it can be insanely scary that it's on by default on all devices because this is used to automatically discover other CDP-enabled devices that are directly connected. This can even be used to auto-configure some of their connections. Now, while CDP is extremely useful in network troubleshooting, our threat actors can use it to easily discover network infrastructure vulnerabilities. For example, the CDP information that's being sent out, it's being sent out periodically and as unencrypted broadcasts. This information that is periodically sent out and sent out in an unencrypted format includes the IP address of the Cisco device. It includes the Cisco Internet Networking Operating System version. It includes the platform, and even based off of the capabilities of that model of the device. It even includes VLAN information and more. So here's a graphic pulled off of a protocol analyzer showing a CDP message and ripping it apart in this unencrypted, unsafe protocol reaching out to our end devices. So how can we stop our end devices from receiving this periodic unencrypted CDP laden full of info of greatness? Well, 2 commands. We have no CDP run. No CDP run is put in the global config mode of your device, and that will turn off CDP everywhere on your Cisco device. Or you want to leave CDP on for those inter-network device connections between Cisco devices, but just off on the user interfaces. That would be the command no CDP enable. That's an interface config mode, and that's what you use on your interfaces connected down to end devices. We also have LLDP, which is Link Layer Discovery Protocol. It's a ventral neutral flavor of CDP. This is also vulnerable to recon attacks. We can turn this off globally in our global configuration mode using the no LDP run command, as well as if you want to do interface specific commands, we can use no LDP transmit and also no LDP receive, respectively.
Right, so I think that's it for videos. Go back to our PowerPoint. There you go. So that is an overview of the 4 concerns we have in this, I believe, last section of our presentation. They did a good job, that gentleman did a good job explaining ARP attacks. I'll let you watch the video again, or maybe go read the content to learn about these attacks. What I want you to do is I want you to know the mitigation techniques. So here, to mitigate the chances of ARP spoofing and ARP poisoning, you want to enable DHCP snooping globally. You want to enable DHCP snooping on selected VLANs, enable DAI on selected VLANs, and configure trusted interfaces for DHCP snooping and ARP inspection. We just talked about this just a little bit ago. What is DAI? DAI, I guess if I had read it, I would be reading it to you right now. Here it is down here. Dynamic ARP inspection. Dynamic ARP inspection is DAI. So related to, and here's a configuration, IP DHCP snooping via VLAN 10, then go to the IP ARP inspection VLAN 10, and then go to the interfaces and IP DHCP snooping trust, and then IP ARP inspection trust. Now, one moment. Okay, she caught it. DHCP snooping is enabled because dynamic DHCP, let me go back. I apologize. You also need IP. I guess we needed to read this, how to address it. He talked about what the actual attacks were, but what he didn't read really was how to mitigate against those attacks. So it's important to mitigate. So you mitigate ARP spoofing and poisoning by using or implementing dynamic ARP inspection, DAI. You implement or you mitigate against address MAC address spoofing by using IP security guard. And then they explain what those are. So in a typical ARP attack, a threat actor can send unsolicited ARP replies to other hosts on the subnet and the MAC address of the threat actor and the IP address of the default gateway. To prevent ARP spoofing and the resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. That's where dynamic ARP inspection, DAI, comes into play. It requires DHCP snooping. You have to enable that first, and it helps prevent ARP attacks by not relaying invalid or gratuitous ARP replies out other ports in the same VLAN. It intercepts all ARP requests and replies on untrusted ports. It verifies each intercepted packet for a valid IP to MAC binding. It drops and logs ARP replies coming from invalid addresses to prevent ARP poisoning. And it error disables the interface if the configured dynamic ARP inspection number of ARP packets is exceeded. And then they show you that here with setting. Remember, we've already learned about untrusted ports and trusted ports. So in order to enable DAI, you have to first configure your DHCP snooping, and then the command to enable DAI is the command ARP inspection VLAN 10 ARP inspection trust. This is probably one of the more challenging commands because it's not connected at all to the actual words. It is dynamic ARP, and the I stands for inspection. Dynamic ARP inspection, dynamic ARP inspection, dynamic ARP inspection. So IP ARP inspection is the command to enable dynamic ARP inspections. I really believe no presentation should be longer than an hour because at the end of an hour talking, my brain is mush and I'm the talker. So I can only imagine your brain as a viewer. But a dynamic ARP inspection, the command to enable it is IP ARP inspection. Not that hard. And then you enable it on the VLANs, and then you go into any interface that you want to also enable the command. And again, IP ARP inspection enables DAI, dynamic ARP inspection. IP ARP inspection trust, or what you put in there for non-trust. Okay. Here, the dynamic ARP inspection can also be configured to check both destination and source MAC and IP addresses. Destination MAC checks the destination MAC address in the Ethernet header against target MAC address in the ARP body. Source MAC checks the MAC address in the Ethernet header against the sender's MAC address in the ARP body. And the IP address, it checks the ARP body for invalid and unexpected IP addresses, including the address 0000 and all 255s and all IP multicast addresses. And in the IP ARP inspection validate. So again, you're throwing in some question marks. So if you can remember, DAI is configured by typing IP ARP inspection, then type a question mark to get to validate, then type a question mark to figure out what the additional commands are. So validate, when you do a question mark after validate, you've got destination MAC, IP, or source MAC. Those are the three things we were just talking about on the previous screen. Now, the key to this is that you can't just turn all three of them on. Because if you turn all three of them on, guess what? When you do a show run, you're only going to see the last one. And the reason you can't turn them all on individually like this is because they overwrite the previous one. So regardless of which order you put them in, only the last one is going to be left. So the way you need to put this command in is IP ARP inspection validate, and then you have to do them horizontally all at the same time, and then it will show up all at the same time. Now, not any other command to this point that I can remember had you enable multiple things on a single line. So this is a challenge, and this is one of the reasons that you're better taking this class with me, because just write it down in your tech notebook and you'll be ready to go for the exam. Not the exam, the written exam, multiple choice, pretty easy. But when you actually do your packet tracers and NetLabs, and then later on the final project, you need to have this command ready to go just in case you're asked to enable it. Okay, so again, this is for mitigating ARP attacks, and it's IP ARP inspection. Hey, if you just remember mitigate ARP, it's IP ARP question mark, maybe that'll get you to inspection, and then you get a question mark after that. So not too challenging. All right, that last concept, mitigating STP attacks. Network attackers can manipulate spanning tree protocol, as we saw in the video. To conduct STP manipulation attack, the attacking host just broadcasts STP bridge protocol units, BPDUs, that are appealing to everybody in the network, and then everybody transfers over to the attacker. It's mitigated by implementing BPDU guard on all access ports. BPDU guard is discussed in more details later in the course, so we don't actually give you those commands at this point. Now, the final, I was wrong. Here, let's just keep going. I'm running out of time. I only got a few minutes left. The Cisco Discovery Protocol, CDP layer. Remember, that's how all the devices talk to each other and can pass information that is quite revealing. And the way you stop that, now there's two different commands for CDP. There's CDP and there's LLDP. Now, if you want to disable CDP, which is a good idea, on your internal equipment, then you want to do no CDP run, and that turns off globally everything on the internal equipment. Now, if you want to turn it back on again, it's just CDP run. Now, if you want to disable it on a port, then you want to do no CDP enable. Enable, that's the key. And enable, that stops any transfer of information back or forward. Now, LLDP separates that out, and LLDP does no LLDP transmit and no LLDP receive, two different commands. Now, I think we already covered CDP in this course earlier. If not, we will later. And I think in the NetLab, there's some weird thing going on with LLDP. So if for some reason you get to LLDP and you get an error message that those commands that you entered do not work, don't worry about it. Just skip that part and put a note in the lab, in the PDF that you send me, saying that it did not work, what the error message was, and you'll get full credit, no problem. It has to do with the equipment already being enabled, so you can't enable it. I'm not sure what the problem is. I have a note someplace about that. All right, so we talk about port fast and BPDU guard. Recall that the network attackers can manipulate spanning tree. This is just reiterating, and this is where we talk about port fast. Port fast immediately brings a port to the forwarding state from a blocking state. We learned that back when we talked about STP. Apply to all end user access ports. You don't want that learning state that allows for something to be able to learn or listen and learn. You want to avoid that. Now, BPDU guard immediately error disables a port that receives a BPDU. Like portfast, BPDU guard should only be configured on interfaces attached to end devices. You should not be getting BPDUs from access ports, right? They don't, PCs, laptops, etc. don't send BPDUs. Only layer 3 devices do, to be able to communicate. And so you have to be, let's see, hang on a second. Yeah, root bridge. So we're talking about, I'm sorry. We're talking about switches. Spanning tree protocol is for switches. I apologize. BPDU guard disables a port that receives a BPDU. So the switch should not be getting the packets that get sent around between switches should not be coming from an access device. And here they show it. Again, port fast bypasses the STP listening and learning states to minimize time that access ports must wait for an STP to converge. Only enable it on access ports. Obviously, if you enable it on switch ports, trunk ports, you're going to have a problem because you're not going to give it time to learn the state if it's made the active switch. Port fast on inner switch links can create spanning tree loop. So you don't want to put port fast on inner switch links. Port fast can be enabled on the interface. Use spanning tree port fast. That's the command right here. So you want to deal with, make sure it's an access port first, and then spanning tree port fast. Write it down, memorize it, practice it. It'll become second nature until you don't use it for 6 months. Then Google it. Globally, use the spanning tree port fast default to enable port fast on all access ports, but on only access ports. So if you haven't configured it as an access port and then you access it, then you still need to go back and configure your port as an access port first. To verify that port fast is enabled globally, you can use either the show running config begin span, which is spanning tree, or show spanning tree summary command. And to show it's enabled on an interface, then it's show running config interface, and then whatever the F01, whatever. And to show spanning tree interface, F01 detail command to get more user validation. And then an access port could receive an unexpected BPDU accidentally, or because a user connected an unauthorized switch to the access port. If a BPDU is received on a BPDU guard enabled access port, the port is put into error disable state because it realizes there's somebody probably hacking into your system. This means the port is shut down and must be manually re-enabled. Remember, you got to shut down before you can type no shutdown to bring it back up again. BPDU guard can be enabled on an interface. Use the spanning tree BPDU guard enable interface configuration command. And globally, you can use the spanning tree port fast BPDU default global configuration command to enable BPDU guard on all access ports. Guess what? You're going to do a packet tracer, you're going to do a lab, and you're going to go get a drink, I think. I don't know, something like Coke. Like, no, don't drink a Coke right now because you are going to want, well, maybe you want a Coke. If you're going to go do that homework right now, you're going to be up all night trying to learn these concepts. All right, so that is my presentation for today. I'm not sure that moving all of the information to this lab made it better. I think it ended up just kind of duplicating a lot of what I covered. I really need to go back into that presentation and delete a bunch of the duplicated content to be able to probably knock 15 minutes off of this presentation. I did tell you it was going to be an hour to an hour and a half long, and right now we are right at an hour and 18 minutes, so I am right about where I said I was going to be, and about 2 hours for both presentations, so we're not doing too bad. Remember, this class is supposed to end at 10 o'clock. We still got an hour and a half. My brain is mush. I'm going to go eat dinner. I hope your brain isn't complete mush. At least after you review the content and do the labs. I hope some of this stuff sticks because all of it is important to keep your interfaces and your equipment safe. There are bad guys out there, and I promise you they're going to try at some point to break into your system, and you need to be prepared for them. My name is Don LaFon, Professor Don. It's been my pleasure to review this material with you. If you have any questions, hang out a minute. I'll try to answer them. Or ask your questions in the help discussion forum, and we'll all help to understand these. Challenging, but not really too hard. It's just a lot of concepts that we've covered tonight. Have a great night.